Okay, once again, kumusta o welcome back to our discussion and welcome back to our channel. So this time we will be talking again, no, in topic and inexact differential equation. So this is the second part and this is a continuation of the previous discussion. Okay, so this is how to find, just to recall now, how to find the integrating factor because the DE here is actually inexact when it is given. So we are looking for an integrating factor, no? So that if this expression will be multiplied to the original inexact DA, then the DA will be converted into an exact. And we are done with the first two, no? So case 1, case 2, and then we have to try using case number 3. Okay, so we are given a DA like this. Okay, so when we are going to test for the exactness of this DA, so this is your M, and what's your M equal to? So it is Y plus the X squared Y cubed, no? And the second coefficient denoted with N, the coefficient of dy is X, no? Now differentiate your M partially with respect to Y, no? Now the derivative of Y with respect to Y is 1. So y cubed becomes 3y squared. So x squared is a constant factor. So the derivative, the partial derivative of your m with respect to y is 1 plus 3x squared y squared. Now if you go with the second coefficient, your n, which is x, differentiate that also with respect to x and its derivative is equal to 1. Now we notice that the two are not equal. So that's why we can conclude that the DA is inexact. Now, as a continuation to find the IF, then I have to get the difference of these two partial derivative. Partial derivative of m with respect to y is subtracted with the partial derivative of n with respect to x. So, 1 is eliminated. I have an expression left which is 3x squared y squared. Now, you have to look for, okay, so the first two possibilities to divide with n. And what's your n? X. So if you divide with x, now we cannot produce a function in x. No? So that's why ang atong case number 1 is not okay. Case number 2, if you have to check, you can also divide with this coefficient. And again, di gina mo produce a function in y which is the expected result. So we can proceed with a third. Okay, so what's the third? This two, the difference of these two partial derivative is 3x squared y squared, no? So, we have to equate that with this expression. Okay, so we have the substitution made. Okay, following case number 3. Okay, this is intended for determining the power of x and the power of y, which are actually your m and n, no? So, this is the equation that we're going to follow. Okay, so substitute the difference of the two partial derivative, and we have this as evaluated. So we have 3x squared y squared. Now this first term, m times n over x. So this is a non. Our n is actually kine, x, and it's divided by x. So we can eliminate our x. No? Okay. So that's why we have m below. Okay. Now the second term is n multiplied by m. Now then I made my y be expressed as a factor because there is also a divisor of y here to remove this one. No? So when y is factored out, then the expression left is 1 plus x squared y squared. Actually, this is produced by removing a common factor of y. Okay, so y is eliminated. So this is now the simplified result. No? So we have m minus n times a quantity, 1 plus x squared plus x squared y squared. Okay? Now, I try to group terms involving constant and a term containing x squared y squared with their corresponding coefficient. No? By the way, the constant term is a minus n, and for the x squared y squared term, do na say coefficient of minus n. Okay? So, to proceed, okay, so we have this, no? Then, in order to find your m and n, so it can be done by equating coefficients of constant coefficient of similar terms, no? Like for example, if I have a constant term of a minus n, okay? There is no constant term at the left, no, associated with this, no? So that is why, so if that is missing there, then we can just equate that to 0. but the constant coefficient in the x squared y squared term is minus n here, I'll be looking for a term which is also x squared y squared term at the left, and it exists with a constant coefficient of 3. That 3 is equated to the minus n because this is minus n. So there you have your n, which is equal to minus 3. After knowing the value of your n equal to negative 3, then you can go back to the first equation. No? So m is equal to n from the first. So that means that your m is equal to a value which is minus 3. So the integrating factor v is equal to x to power m y to power n. So this will have a value of minus 3 and minus 3 also for your y as their powers. Okay? So the IF will be multiplied to the given DA. The purpose is to arrive with a DA which is exact. Okay? The original is this one. So I'm going to distribute my IF identified. So this is now the resulting equation. No? So x to power minus 3, y to power minus 2. No? Kana, when that's distributed, then plus x to power minus 1 because that's minus 3 and that is squared. No? X squared. So your y is eliminated. No? Because your y here will contain a power of 0. No? So that's 1. So it is x to power minus 1 that is left. We have a dx term plus. Okay, how about kini? This is x to power minus 2 because there is 1 here. So you just copy your y with power of minus 3 dy. If you are in doubt whether what you produce is really exact, so you can retest for the exactness. The partial derivative of m with respect to y, this is your m, no? This one. So is equal to minus 2 y to power minus 3. Okay, times the x to power minus 3. So muna iyahang partial derivative because this is already 0 because the differentiation is done partially with y, no? In the second term, it is differentiated also with respect to x. So it's minus 2 x to power minus 3 y to power minus 3. So the two partial derivatives are actually the same. So that means I can conclude that the dA produced is really exact. So I can now go with the value of my f, no? From this equation, no? Which is already exact, no? So I can integrate my first equation, no? So we have an f from these terms, no? Or from the dx term. So integrate partially with x and you can produce an unknown function involving y, no? After integration. So the terms are this one. Okay? Integrate with x, so y squared is constant. So according to power rule, I have to increase the power by 1. So that's minus 2 over the n plus 1. Okay? So plus. This is x, so this is dx over x because the power is minus 1, no? So you cannot use a power rule but follow the dx over x form which is having an integral of L in x plus the unknown function involving y. So this is an answer but only I need to have the gist of y if that exists, which is possible to get out from the dy term, no? So what's my f according to the dy term? So we have the integral of n dy plus the unknown function in x. Okay, so integrate with y partially. So x squared is a constant. So my integration will be done with y to power minus 3. Increased by 1, that is minus 2 as new power over the n plus 1 which is minus 2. Okay, plus the unknown function. Possible answer from my second term. Okay? Now, for your final answer, this is composed of several terms, no, or more terms compared to the second. So I can collect the terms out from E1. And if there is a gist of y there, or purely y terms, no, then I have to consider that one. But unfortunately, or ang atong gist of y there, that is actually, no, a function which do not exist in A2. So it's good because the only answer, or the answer, can only contain these terms, no? So your f there is actually involving this one, no? And your f is equal to C. So I can just have these terms, no? Converting the power to positive, taking the reciprocal. Okay, so minus, okay, 1 over 2x squared y squared plus the L in x. There is no purely y term. Okay, so this can now be your answer. You may prepare to remove the denominator. It can also be, but okay lang sa, di mong answer will be expressed as that. Okay? Now, the secant is different. Okay, so this may lead in either case number 1, 2, or 3. Okay, so yun. So my m, I try to distribute my 2y Okay, so these are the product, or this is the product of this when it's multiplied, and that is x squared minus 2y as your n. If I'm going to test for the exactness, no, so the partial derivative of m with respect to y is, this is 2x squared, correct? This becomes 1. Derivative of this with respect to y is 4y. This is 2x because y becomes 1. When differentiated partially with respect to x, this will produce 2x, correct? Okay, and this is 0. Okay, so you can subtract because this is inexact, so I have to get the difference of the two partial derivative. We have 2x squared minus 4y, the 2x is eliminated. Now notice that 2 is common, so I remove 2, and there is another factor which is x squared minus 2y. Okay? Now I have to check now with the coefficient of dx and dy, now which coefficient will be used as a divisor. So ako na lang i-inspect, no? Now if I'm going to divide with n, now I think this is the best, no? Because the function containing x and y can be removed, no? Okay, if this is used as a divisor, but ugarikudare, dividing with m, so I cannot go with a function that is purely y, no? So, by inspection, no, din lang ko mayong try 1, try number 2 case, then case 3. So, I can use directly by inspection, so I can have a divisor of n to the difference of the two partial derivative. Now, try to look at the result. So, this is the difference of the two partial derivative. This is my n placed in the denominator, and I can remove this. So, this is out, and this is involving xy. So, the result is actually a constant. The expected function resulting from a division by n is a function that is purely x. So, if that's a constant, then I have to treat this constant as a function in x. Then we can proceed finding the if. Okay, so if by formula is the exponential of the integral of f of x, this result, dx. So we have an exponential of the integral of 2 dx. Okay, so that is 2x when that is subjected to integration, or that is exponential 2x as your if. That if will be multiplied to the d. Okay, so this is now the resulting equation. Okay, so all the terms involve an exponential 2x. Okay? Then you may recheck for the exactness. Okay? Retesting for the exactness. Partial derivative of your m, this is your m, with respect to y. Okay, so this becomes 1. So what is left is only the constant coefficient. Constant with the function in x. So we have, okay, a term free from y because this becomes 1. Kine, this is a constant. The derivative of y squared with respect to y is 2y. That is why for the entire term, we have minus 4y exponential 2x. This one, this is y with power 1. Its derivative is 1. So what is left are these functions in x and a constant. Okay. Now, I have to wait for the result of the secant coefficient, no, from the dy. Now, if that's differentiated with respect to x, will it produce the same result as the previous? Okay? This is all in x. So, you can apply a product rule. So, we have x squared with exponential u form. So, it is exponential u, okay, which is 2x. And the derivative of u with respect to x is 2. So, next, exponential 2x, the derivative of x squared is 2x. This one, 2y is constant, or minus 2y is constant, exponential u times the derivative of u with respect to x. So, I have to compare this result if all these terms are also present. This one is actually this term, correct? This is your last term, di ba? And this is the middle term, okay? Which is equal to the last term in the secant partial derivative. So, it shows that the two partial derivatives are now equal. Thus, the DE is accurately provided with an IF, or the integrating factor of x to power minus 2. Now, you have to solve for your f. Okay? So, if from this equation, which is already exact now, so I have two options. I can simultaneously integrate both, no? But if you notice, if I'm going to integrate my first term with respect to x, no? So, this is a little bit complicated, no? Why? This will involve what role of integration? An integration by parts, no? So with this, no? So this is complicated to integrate directly. So instead, I write this, I collect this equation, and call this equation 1, and I consider my second equation, ako lang gibutang og derivative form, no? Or partial derivative form. Instead of having f which is produced by integration, so I can have the partial derivative of f with respect to x, no? As my first equation, which is these terms, okay? And the partial derivative of f with respect to y is this coefficient, the coefficient of your dy. Okay, so I call them equation 1, equation 2. I look for the simpler or which of the two equation is easy to integrate. Okay, so I chose my second as my simpler because I noticed that is easily integrable. Okay, so integrate the simpler equation. Okay, now I have the integral of this. Now, so do the integration with y, and these are all in x. So meaning, this is just a constant term which can be placed before the integral sign. So if I do the integration, I have to integrate only a dy. And the result is y. That is from the first term. The second term has the coefficient or a constant coefficient of minus 2 exponential 2x. So you have to integrate y dy. So y squared over 2. So that makes your 2 be removed. Okay, so this is the integral of your second term or second equation, I mean the simpler one. I can introduce an unknown function which is purely x because we treat our x as a constant. So this can be an answer if I know what is the function in x. So I'll be solving for the unknown function. I was not able to use yet my equation 1. Okay, so this is the correct procedure of working a DA like this. No? So differentiate your equation A here with respect to x para it can be expressed same as in your equation number 1. Okay? The purpose here is to solve for the unknown function. Okay? So I can differentiate my a with respect to x partially. Okay? Differentiate our f, which is the equation a, with respect to x. And this is expressed as a product. My y is a constant factor, so I can differentiate this function under a product rule. X squared, exponential 2x, that is the derivative, and plus the exponential 2x, 2x is the derivative of x squared. So I'm done with the first term. Plus, minus y squared constant, exponential 2x, that this is the derivative, and the unknown function is, you also obtain its first derivative. Since we do not know what the function is, so I simply put f prime. Okay? So this is equivalent to your equation producer. Ako lang simplify by distributing my y. Okay, so these are the terms out from my out from this equation after doing the differentiation. I call this equation 3. And notice that your equation 3 and 1 are both equal to the partial derivative of f with respect to x. So I can equate 3 and 1. Collecting the terms out from the 3 or equation 3, I equate that to the terms out from 1. No? Now I notice that they are all terms involving xy, which are also present on the other side of my equation. Thus, this term can be eliminated. Okay? This can also be removed with the last term, and this can also be removed with the middle term. So what is left is only the first derivative of the function x, and that's equal to 0. The first derivative is obtained when the unknown function, is differentiated with respect to x. Okay? In differential form, now I multiply with the dx. Dx times 0 is still 0. So this is the differential of your unknown function. Para I can produce my f through integration. Now, so when we integrate both sides, I obtain the unknown function, and the integral of this is also a constant. Correct? Okay, so I can have equation A. Okay, so this is c sub 1, and that's my f equal to. Okay, so I replace my f of x with c sub 1, but f is actually c, correct? So if I'm going to, or a constant, so f minus another constant remains to be an arbitrary constant. That is why, ang ako ding f can be equal, ako lang equate this expression to c. And this is now your solution. Okay, so medyo taas-taas atong pag-solve, no? So, that is if you can encounter a situation where ang atong pag-integrate simultaneously with the two coefficient of the dx and dy, no, is not easy to do. Okay, so we will be looking for the simpler equation. So that is how what the process is, no? So just try to follow that one. Okay? So for now, no? So thank you for watching and see you on the next tutorial video. And again, don't forget to subscribe if you are new to the channel, and I hope you will also invite others to subscribe. Okay? So thank you and goodbye.